Here we have a problem on finding domain and range of a composite function, that is f dot g, where f of x equals to sin x and g of x equals to 2x. Okay, now let's see how to find the domain of this composite function f dot g. Okay, for that, first we have to write the formula for this composition of two functions, that is f dot g equals to f of g of x. Okay, in the composition of two function, what we have to do is first we have to be knowing which is first function and which is second function. So okay, so here we have two functions. How do we have to identify the first function and second function? Okay, in this composition of two functions, for which function can we give input at first? So here in the composition of this function, composition of two functions f and g. So g of x is clearly seen. So we can give input for g of x at first. Since we can give input for g of x at first, this g of x has to be considered as a first function. Let me write it. And the other function f has to be considered as second function. Okay, let me write over here. Okay, now let's discuss the domain. What is domain actually? So for example, let's consider the function g of x, and if I want to find the domain of this function g of x, so there is nothing but the values of x, or the set of values of x for which g of x is defined. So now to get the domain of a composite function, first I have to get the domain of the first function. In this case is g of x. So let me write the domain of the first function, that is domain of g of x. The domain of g of x is what? Let's consider the function g of x over here. So what values can we give for x over here so that g of x will be defined? So here g of x will be defined for all real values of x. So the domain of g of x is all real values. Now I got the domain of the first function. Actually, the domain of a composite function is the same as the domain of the first function. In this case, it's all. Otherwise, the domain of the composite function must lie inside the domain of the first function. That is, the domain of the composite function can be the subset of the set of all real numbers. Okay, so for the first, we have to find the result of the composition of the two functions, f of g of x. For that, f of, we know the stuff for g of x, that is 2x. We can plug in 2x for this g of x over here. Then I'm getting f of 2x. So f of, already we know that f of x equals to sin x. Then f of 2x equals to what? So for that, we have to replace this x by 2x, and I'm getting sin of 2x. Now I got the result of the composition of two functions. That is composite function, that is sin 2x. What is the domain of this, the result of this composite function? So it can be any real number, because here it's 2x. X is a part of the angle of the trigonometric function sine. So we can plug in any angle measure for any real value for x over here. So the domain of the result of the composite function, given composite function, is all real numbers, and the domain of the first function g of x is also all real numbers. As I said earlier, the domain of a composite function can either be the same as the domain of the first function, or the domain of the composite function has to lie inside the domain of the first function. That means the domain of the composite function can be the subset of the domain of the first function. Okay, so how do you have to conclude what is the domain of the given composite function? For that, let me draw a real number line which represents a domain. So here I'm taking negative infinity, here I'm taking positive infinity. Okay, now first what I'm going to do is I'm going to draw the domain of the result of the composite function. What is the domain of the result over here of the composite function? It's all real numbers. All real numbers means I have to draw the entire region from negative infinity to positive infinity. Okay, now I have to draw the domain of the first function, that is g of x. So that is also all real numbers. That is, I have to cover the entire interval. Now, what is the common region of these two graphs? So the common region of these two graphs will give the domain of the composite function f dot g. So the common region is the entire interval from negative infinity to positive infinity. That is all real numbers. So therefore, the domain of the composite function f dot g is all real numbers. Okay, now finished defining domain of the given composite function. Okay, now let me erase some stuff, and let's see how to find the range of the given composite function. Okay, now let's see how to find the range of the given composite function. Okay, first let's understand what is the range of a function. For that, let me consider one of the given two functions, f of x equals to sin x. Already we have seen the domain is nothing but the set of values of x for which the given function is defined. So the range is the values of we can have for the given function. That's called range of the function. So here we have f of x equal to sin x. What values can we have for f of x or sin x, which is the equivalent to f of x? So that's called range. Already we know that the minimum value of sin x is -1 and the maximum value of sin x is a +1. So -1 less than or equal to sin x less than or equal to +1. So sin x can take any value from -1 to +1. So the range of sin x is in interval notation -1, 1, where both -1 and +1 are included. So this is what we have to understand about the range of the function. The range of the function is the values of x we can have for the function f of x or stuff which is equal to this. Okay, now to get the range of a composite function, what we have to do is first we have to get the range of the second function. In this case, it's f. Okay, now let me write the range of the second function, that is f of x. So what is the range of the second function? So the range, actually the second function is f of x here in this case. So f of x equal to sin x. Just now we discussed the range of for the sin x. It's from -1 to +1. So the range of f of x is -1 to +1. Okay, so usually the range of a composite function is the same as the range of the second function that we have over here. Otherwise, the range of the composite function must lie inside the range of the second function. Otherwise, it can be said as the range of the composite function has to be a subset of this interval. Okay, for that we have to get the result of the composite function. I think already we got the result of this composite function. Anyways, so say f of, so for g of x we can plug in 2x. So for f of 2x already we got that sine of 2x. This is the result of the composite function, and now let's find the range of the result of this composite function. So here we have trigonometric function sine, and it doesn't matter what angle measure we have over here. Always the trigonometric function sine will take the values from -1 to +1. So the range of values for this trigonometric function sine is -1 to +1, where both -1 and +1 are included. Now I got the range of the result of the composite function. Already we have the range of the second function f of x, that is -1 to +1. Okay, as I said earlier, the range of a composite function can be the same as the range of the second function, or the range of the composite function has to lie inside the range of the second function. That means the range of the composite function can be a subset of this interval. So now how do you have to conclude? For that, let's draw a number line which represents a range. Let me draw, this is left side extreme -infinity, this is the right side extreme +infinity. Okay, since we have the numbers -1 and 1 over here, and here also we have the numbers -1 and 1, let me draw the two numbers -1 and +1 over here. Okay, now first let me draw the graph for the range of the result of the composite function for the sine 2x. The range is -1, +1, where -1 and +1 both of them are included. Since both -1 and +1 are included, let me draw a filled circle at -1 and filled circle at +1. Let me connect them. So this graph gives a range of the result of the composite function, that is sine of 2x. Now let me draw the graph for the range of the second function f of x. That's also -1 to +1, where both -1 and +1 included. So we'll be getting the same graph again for the range of the second function f of x. Let me draw it here. Okay, now to get the range of the composite function f dot g, what I have to do is I have to find the common region of the two graphs. So the common region is clearly this part. So the common region of the two graphs over here will give the range of the composite function. The common region of these two graphs is -1 to +1. So this is the range of the given composite function. Okay, now let me write it over here. So range of the composite function f dot g is in interval notation -1, +1, or it can be written as -1 less than or equal to y less than or equal to 1. So usually we use the variable y to represent the range.